Let's take a trip into infinity. You may think this would be difficult, but using the Mandelbrot fractal zoom, we can do exactly that.
The Mandelbrot fractal zoom is an image that shows more intricate details the closer you look at it. Let's see how this happens.
Let's start with the concept of complex numbers. So far, you've probably only encountered real numbers, such as integers like -1, 0, +1, and decimals like 0.25, 8.8, and more. These numbers belong to the real set of numbers, which can be shown in a real plane.
However, there are many math problems that can't be solved using real numbers, and this is why mathematicians introduced a complex set of numbers.
When you square real numbers, the product is always a positive value.
Let's look at the example of 1 and -1. When we square the value of 1, we get back 1, and square the value of -1, we also get a positive 1.
But consider the value of square root of -1. Here, the square of the square root of -1 would be a negative number, which would not be possible for real numbers. This is where complex numbers come into play.
The square root of -1 is now known as the imaginary number I, and when we square this value, we get back the value of -1.
A complex number, denoted by the letter z, is equal to x plus iy, where both x and y are real numbers which belong to the complex plane.
Instead of working with x and y axis, the complex plane is set up with real and imaginary axis. The value for x is the units of measurements on the real axis, while the value of y is the units of measurement on the imaginary axis.
If we have a complex number defined by z is equal to -2 plus 2i, to graph it on the complex plane, we must travel 2 units to the left on the real axis, and then 2 units up on the imaginary axis. Where we arrive, that is our point z.
By working in the complex plane, it allows us to explore a whole new realm of mathematics, including the Mandelbrot fractal zoom. To identify the Mandelbrot set, the equation Cn equals Cn minus 1 squared plus z is used. In this equation, z is our complex number, and c to the n minus 1 is the value of the previous index of the set.
But can we just pick any random set of numbers and zoom in? The answer is no. To be a part of the Mandelbrot set, the set of values Cn must produce a continual loop of the same values repeating over and over again. If this occurs, then we know that the complex value z is a part of the Mandelbrot set.
So, let's go back to our example of -2 plus 2i as our complex number. Using this, and plugging it into the Mandelbrot equation, we can see that for our n equals 0 set, we would have a value of 0. For our n equals...
Created using Powtoon.